Assalamualaikum and hi everyone. In this video, I will show you how to calculate cost minimized diet for secondary school students by using linear programming. Before that, let me introduce our group members. The first one is Nurul Haziqah binti Ab Razak, followed by Nurfariyana binti Jasni, then Nur Adila binti Rosdi. The last one is Najihah binti Ahmad Rasidi. The reason why we choose this topic is that nowadays, in order to maintain a healthy lifestyle, food and diet selection has been one of the main concerns for humans. But as the prices of food in Malaysia is continuously increasing due to various factors, make the people, especially the students, tend to neglect a healthy eating patterns and consume insufficient nutrient per day. Do you know why the students tend to neglect a healthy eating patterns? This is because students are obligated to spend as minimum as possible every day. Humans need to eat good and balanced nutritious diet that provide calories for energy requirements and nutrients for proper growth, repair, and maintenance of the body tissue. This leads to a lot of complications such as diseases, sickness, and lack of energy to focus in the class. Because of that, a survey was distributed to the secondary students as respondents to collect information regarding their daily diet patterns. Using the data, linear programming models of diet problems is set up and solved to determine the minimum cost which satisfies the daily recommended nutrient. Why we use linear programming to calculate the cost minimized for the food? This is start from here. Today, busy lifestyle habits drastically change the pattern of eating, where people are more likely to have irregular meal times and cost of food may be expensive for them. Therefore, some studies are conducted to find the minimum cost that satisfies the daily nutrient requirement. Based on selected literature, linear programming can be applied to a variety of diet problems from food aid, national food programs, and dietary guidelines to individual issues.
Methodology. Data collection. A set of questionnaires was distributed to the subjects. Basic information such as age, gender, and meals prepared by canteen standard chosen is collected. Based on the subject's diet history information, a food list is prepared and the price for each food items was obtained. The food list was obtained from the Ministry of Domestic Trade, Cooperative and Consumerism (KPD and KK). The food prices were set in terms of price per serving size. Statistical analysis. Excel solver was used to determine the optimal food portion size that met all the dietary and nutrient recommendation of MDG 2010, MDGCA 2013, and RNI 2017. For the sensitivity analysis, we use Lindo solver to determine the allowable value. Linear programming model development. Here are tables for recommended daily intake for students during lunch and table for choice of common food sold at the canteen. As you can see here, the recommended daily intake of carbohydrate for lunch is 80 gram, while 20 gram for fat and 30 gram for protein. For the second table, you can see the prices for choices of common food sold at the canteen, such as plain rice, fried rice, nasi lemak, fried chicken, and so on. Nutritional content of menu. Here are the content of carbohydrate, fat, and protein for every menu on the left-hand side of the table. For example, in a plate of plain rice, there are 26 grams of carbohydrate, 2 grams of fat, and 2 grams of protein. Based on the recommended daily nutrient table for students at lunchtime, the linear programming model is shown as follows. Here are the general equation for objective function and the three constraints. The objective function, we minimize z equal to k1x1 plus k2x2 plus k3x3. KN is the cost of menu, while SN is the menu of type. And we get three constraints, which are AC x1 plus AC x2 plus AC x3 greater or same as 80. And the second constraint is AF x1 plus AF x2 plus AF x3 greater or same as 20. While the third constraint is AP x1 plus AP x2 plus AP x3 greater or same as 30. X1, X2 and X3 must greater or same as 0. AC is the amount of carbohydrate, while AF is the amount of fat, and AP is the amount of protein.
Next is results and discussion. Based on the survey answer given by student, 50% of the student choose set 1, 42.3% choose set 2, and only 7.7% choose set 3. So, we have decided to choose set 1 and set 2 to be calculated as higher demand by students. The data collected are calculated using Microsoft Excel solver. For the set 1, we have nasi lemak, fried chicken and curry puff. Every menu have their amounts of carbohydrate, fat and protein. Amount of serving for each menu will represent as X1, X2 and X3, where X1 is amount of serving for nasi lemak, X2 is amount of serving for fried chicken, and X3 is amount of serving for curry puff. So, from this set, we can get the objective as the minimize of Z is equal to 2.5x1 plus 2.5x2 plus x3. For constraint, we have three constraints, which is for carbohydrate, fat and protein. For carbohydrate, we have 58x1 plus 10x2 plus 21x3 more than and equal to 80. For the fat, we have 13x1 plus 21x2 plus 6x3 more than and equal to 20. And last, for the protein, we have 9x1 plus 14x2 plus 3x3 more than and equal to 30. So, x1, x2 and x3 more than and equal to 0. Using the Excel solver, we get minimize of Z is equal to 6.4. It means 6.4 is the minimized price for set 1. For amount of serving, nasi lemak, we get 1 plate per serving, and fried chicken, we get 1 pieces per serving. While amount of serving for curry puff is 0. Next is set 2. In set 2, we have fried rice, grilled catfish, and nugget. Amount of serving for each menu will represent as X1, X2, X3, where X1 is amount of serving for fried rice, X2 is amount of serving for grilled catfish, and X3 is amount of serving for nugget. So, from this set, we can get the objective as the minimize of Z is equal to 3.5x1 plus 3x2 plus x3. For the constraint, we have three constraints. Constraint for carbohydrate is 50x1 plus 70x2 plus 10x3 more than and equal to 80. For the fat, we have 4x1 plus 20x2 plus 18x3 more than and equal to 20. Constraint for protein is 4x1 plus 26x2 plus 17x3 more than and equal to 30. So, x1, x2 and x3 more than and equal to 0. Using Excel solver, we get minimize of Z is equal to 6.0. It means 6.0 is the minimized price for set 2. For amount of serving, fried rice, we get 1 plate per serving, and nugget, we get 1.5 or 3 pieces per serving, while amount of serving for grilled catfish is 0. The following are two of the lowest cost diet found. The first one, with the cost of 6 ringgit, student can get 1 plate of fried rice and 3 pieces of nugget. And the second one is
With the cost of RM6.40, student can get 1 plate of nasi lemak and 1 pieces of fried chicken. So, I think the set that have been chosen by student are reasonable and affordable. This is because this set have sufficient nutrient with low cost for the student lunch time.
Sensitivity analysis. The main purpose of sensitivity analysis is to identify the parameters that cannot be changed without changing the optimal solution. The analysis also helps researchers to know how far the input parameter values can vary without causing changes in the optimal solution. Sensitivity analysis of set 1. This sensitivity analysis was solved by using the LP solver, which is Lindo. Based on this output from Lindo, we can see that X1, which is nasi lemak, can increase the price by 40 cents, becomes the new price RM2.9, and we can also lower the price by 90 cents, becomes RM1.6. X2, which is fried chicken, can increase the price by RM1.4, becomes RM3.90, and we also can lower the price by RM2.10, becomes 40 cents. For the X3, which is curry puff, we can increase the price with any price that we want as the data is infinity. And we also can lower the price by 10 cents, becomes the new price 90 cents. Next is sensitivity analysis for the set 2. We also use Lindo solver to get the sensitivity analysis. Based on this output, we can see that X1, which is fried rice, can increase the price by RM1.50, becomes the new price RM5, and we also can lower the price by RM3.30, becomes 20 cents. For the X2, which is grilled catfish, we can increase the price by any price that we want as the data is infinity. And we also can lower the price by RM1.4, becomes RM1.60. For the X3, which is nugget, we also can increase the price by 90 cents, becomes RM1.90. Also, we can lower the price by 30 cents, becomes 70 cents. For the row 2, 3, and 4 are the carbohydrate, fat, and protein respectively. One of the benefits of sensitivity analysis is that it presents decision makers with a range of outcomes to help them make better business decisions. Conclusion. The diets discovered from this research might only be the best suited for students in secondary school. This is because the menus considered in the LP models are chosen based on the menus easily available for the students, and the daily recommended intakes are based on the age of the students. Therefore, it is very important to select good choice of food in order to satisfy the daily recommended nutrient intake.